Finally, I can publish 4 large images at about 30 Hz from my virtual robot simulation with minimal delay. The data delivery is quite smooth without ROS, and I am very satisfied. So, how much do you like ROS? If you're like me, you must have been looking for some alternative tools than ROS. If so, what did you find? Well, ROS does offer some convenient tools and frameworks. However, all these set of frameworks can be a jail at the same time. However, it's not so easy to find a tool that spans all these ROS features because ROS does provide entire ecosystem with it. However, if you can narrow down your needs and prioritize your needs, there are actually a couple of sexy, minimalistic message delivery tools that you can use right away. And in this video, let me talk about that, and stick till the end of this video because I'm going to walk through a couple of demos of these tools as well. So if you're new to here, my name is Elliot. I'm a robotics engineer and educator. My mission is to help people learn the field of robotics as smooth as possible. Okay, today let's start from this Reddit post. Like, what do people use instead of ROS2 for robotics? Because I like this kind of topic, and then I can see a lot of discussions going on in this topic as well. And then some people are really angry with ROS2. Some people are kind of neutral. And I think I'm a little more biased against ROS, personally saying. But I think there is a valid reason. So let's look at this post first. Some people just argue that just plain C++, which means the monolithic app that does everything, so you don't even need distributed computing, because this person is working with 4K images at 30 FPS without wasting 3 cores solely to serialize. And this, if you're not familiar with this concept of serialization and deserialization, I will talk about that in a few seconds, so stick to it. And I do have the same problem like this person, but for some reasons, I don't do monolithic applications because it's not that critical. But if it is critical, I totally agree with this person. And yes, the serialization is a huge cost. And then this person is, if you want to build an old-fashioned robot, you use ROS and fight with old Ubuntu's and Docker and giant files and dependencies and so on. And then what kind of fighting are you talking about? You can just apt install ROS Humble Desktop and so on, and that's simple. Yes, it is that simple. However, when it comes to robot operation, it's not just about a single robot. You are talking about the fleet of robots or swarm of robots, and then cloud server is involved, and then the users, the end users, they are the problem because they are not engineers and they will never open up a Ubuntu terminal and start typing ROS2 topic list. So that's the beginning of the problem, and that's why we can't just do this. Let's talk about that too. Also, this guy says, I never understand when people say things like use Zenoh instead of ROS2. You can use Zenoh instead of DDS and keep using ROS2 with Zenoh. I'm kind of put off by a number of things about ROS2, but I don't know anything else comparable. I also agree with that because ROS provides entire ecosystem. This thread is saying ROS is a horrible way of building robots, and for some reasons, why not? When building a complex robotic system, ROS provides modularity and interpretability and lots of tools for debugging and visualization of data being transferred between components. At least this is what I have found so far. I totally agree with you, and that ROS is the most convenient tool for this. However, I found another way achieving quite similar things like this without using ROS. For example, when it comes to data visualization, you can use rerun.io, or you can also custom develop the UI for the data monitor system if you are okay with that. This guy actually points out some drawbacks of ROS. It says it forces an operating system version, it directly forces hardware platform on you, and it forces language version, a lot of forces, right? So it means he found the ROS ecosystem as a jail. It's a dictatorship. So this is something that I agree the most, because when it comes to software design, probably if you're like me, you might want some architecture-wise freedom. Like even when it comes to the folder architecture level, there is some kind of rules that you gotta follow. You have to put the packages under src folder among entire ROS workspace. And then these dependencies as well, like OpenCV, and ROS does come with OpenCV version. And then if you need to use different OpenCV version, you need to configure this dependency path by yourself. So if you are a big fan of following just the first principle and then have the freedom of your own design, then ROS can be literally a dictatorship. It is a double-sided edge. And honestly, I couldn't find still until today any perfect alternative tool than ROS. That being said, if you know what you're doing by first principles, there are some couple of alternative tools that you can use. So before I talk about everything, let's talk about the problems of ROS on a very high level, and then I'll talk about why exactly that's the problem for robot development. Then I'll go over these alternative tools that I use every day. So on a very high level, people are talking about in the Reddit post the problems ROS in. There's the dependency issue, and then coupling issue, and the serialization issue with the ROS. So what are those? That's my question. So again, in a high level, the ROS comes with the message delivery system and the message serialization, and then the packages and build tools. And these two are bounded by this ROS middleware here. And then application layer is about these build systems and other tools like that. And by the way, this is a really interesting survey. I did it on my YouTube channel. 80% of people like ROS because of these packages and tools and off-the-shelf and free applications like nav2, control, and so on. And actually, I'm one of them, and that's why I'm using it. And then it's really interesting that I have an impression, not just from this survey, but just around my circle, people seem to care less about message delivery system and the message serialization. And I think this is one of the most important things for robot applications, because robot applications is oftentimes come with these time-critical missions. What's the time-critical mission? It's literally a self-driving car. You have to step on the brake as soon as possible, if it has to. And then you don't want an uncontrolled delay between the applications, because a few milliseconds of difference in the reaction time can make a huge difference. And literally, when it comes to racing car drivers, they have just a few milliseconds faster reaction time than average drivers, and that's a huge driving performance. And same goes for the robots. And that's all about this message delivery and the serialization here. And that's exactly why some people use monolithic app for their applications for robots. And this is another very easy to understand example that people are talking about the design dictatorship, because you gotta put your packages underneath SRC to be able to build the package. And it's not too much of a design, but it's one of the very typical example that the ROS dictate you where to put what. And that's exactly the coupling problem here as well, because if you just want to use message delivery system, you have to use the other two, no other way around. And what do I mean by that? I don't know why most of community are focused on the single robot development, but in practice, there are a bunch of robots like swarm of drones and a fleet of robots are working together with the cloud server and then mobile application from the end users. And they got to communicate with each other, obviously, and then serialization is a big problem, and then ROS cannot handle it well, because robots at the end of the day, they are just a bunch of different processes in different programming languages, and then they got to communicate. And the problem is the serialization, because different programming languages use different byte array representation for their variables, then they gotta use some kind of standard serialization protocols. And out there currently, there are like protobuf by Google, FlatBuffers, and the ROS2 has its own idle like ROS interface, Mavlink for the UAV, and it's coming from radio telemetry. And then they need to communicate with all each other, and then when they have different communication protocols, that's a problem. Why? Here's a very example that I went through. So UAV send Mavlink message, and then server, the backend engineer will send probably using protobuf, and then mobile app developers are using FlatBuffers, and then you as a robotics engineer, if you use ROS, you're probably building all these bridges and managing all this message conversion from FlatBuffers command ID to ROS specific command ID and so on. And then say you have built all these bridges and managing all that, and then on a very peaceful Friday after, the backend server team will send you a message. If they actually do that, that's very nice people, because they notify you at least. But the thing is, you have to update these message definitions for each bridge, and then it will happen next week again from the mobile app developers and then UAV developers and so on. And then all of a sudden, your job is managing all these bridges instead of developing the cool robots. So if you don't want to do this, you have another choice. If you use byte array as the raw byte array as it is with the raw standard messages, and then you can use ROS2 topic echo my topic, and what's going to come out? The byte array will come out, and then RQTRVs and other tools like Gazebo will not work with this byte array, because you are not using the ROS specific message serialization, and the ROS tools do not understand this byte array, and then all of a sudden the ROS is useless. So you have two choices. Stick with this or managing all these bridges like this. I choose the freedom over the dictatorship of ROS. However, there's one assumption here. So for example, when it comes to ORB/SLAM, it's not ROS specific package, it's a standalone C++ project. And then only if you are familiar with CMake or Bazel like building system, you can get out of this dictatorship. However, I was honestly saying one of these group. I was kind of scared of learning CMake and then new building system. So I was just like sticking with this Qualcomm build ROS specific system, and that's one of the very big reasons I was not able to find my freedom. However, if you're really dealing with these time critical projects, these bridges is not only easy to maintain, but also at the same time, the bridges and the serialization itself is the bottleneck, and then it will reduce this performance of your robust reaction time. So if you can, why don't you just remove this uncontrolled latency? And that's my argument. So what now? You can divide message delivery system, message serialization system, and then you can just integrate them using your first principles. So one tool is Zenoh. I'm not talking about, by the way, Zenoh ROS middleware, but standalone Zenoh. And then another one is iceoryx. The big difference in between them is the shared memory. Zenoh does offer the shared memory for C++ only. However, iceoryx2 is pure shared memory based framework, and it supports many languages, and they will be supporting more languages in the future. So the choice is yours. So the good thing about standalone Zenoh is that it's easy to build and easy to use, and that it can be used for physically separated or geologically separated machines, and it's still straightforward. And another thing is iceoryx. This is iceoryx GitHub. You can always build it by yourself. And then here is the benchmark. A very interesting behavior of iceoryx is that, as you can see, this is green line, that's the iceoryx2, and as the payload size increases, the latency is a constant. I think that's a big advantage of this framework compared to, say, other transport-based message delivery system. So if your project is super duper time critical, I definitely recommend this iceoryx2. I'll show you my simulation result as well. So this is a Unity-based game simulation, and then I'm literally sending these about 15 megabytes of images at 30-ish hertz, like 20 to 30 hertz. And as you can see, the delay is really minimal. And I love this because the Unity offers like WebRTC, something like game streaming framework there. However, it uses codec itself is another bottleneck because you have to compress and decompress the image, not only the serialization, and that is going to be the huge latency there. However, using this shared memory, iceoryx2, you don't have to waste your time serializing and deserializing the data because you can just directly share the image. Only delay here is the Unity itself because I have to grab the data from the GPU, and then RAM data can be directly shared by these Python applications for 2 subscribers. And there are 2 images, by the way, because this is the stereo images, one for left camera and then for the right camera. First, let me go over a very simple Zenoh Python code here. To install, you just need to do pip install eclipse Zenoh. Now that's all I did. You don't have to install any grandiose packages like ROS and so on. All I need is just installing this Zenoh package for Python. And then as you can see, the code itself is pretty simple. You just define the Zenoh session, which is more like a ROS node, and then you define the publisher, and then literally start publishing your data like that. Then the same for the subscriber is based on the callback listener here. So if I run Python sub, that is ready, and then Python publisher, and then as you can see, just message publishing subscription is done like that, period. No other packages. And then this is language agnostic, so you can send any binary messages like that. So it doesn't dictate any byte array type. So it can be FlatBuffers, protobuf, and so on. Okay, that was Zenoh, and this code is iceoryx. Here, I just prepared C++ and then subscriber in Python, C++ publisher like that. Everything is same idea as before. Here, publisher alone, it means literally you want to allocate some uninitialized free RAM space. And in that sample, you are putting all these images as an example. Like that's the publisher. Let me just run the subscriber first. Once I run that, the subscriber has empty image view because it's not subscribing any data because there's no publisher. On the publisher side, publisher is publishing the images like that, and then subscriber is subscribing the images in both OpenCV. One is C++, one is in Python, and that's it. As you can see, there's no delay. I achieved it without ROS. As long as you're comfortable with this standalone package build system, you'll be able to taste the freedom outside ROS. And this is my last example about FlatBuffers. Unlike the previous two, this is about message serialization protocol. So just like ROS idle file, you can define the message definition like these names and then types of the variables. Here, this is flatc.exe that you can download from their GitHub repo. And then if you just run flatc python data.fbs, which is the name of this data definition file, and then it will just create this automatically generated Python script to serialize and deserialize these messages. So if I just run python main image, here I write this code to serialize the message like that, like image.image add fx fy, and I just put some random values here. And then I just added images as well. In this case, serialize the image like image vector office build.create RGBA bytes. However, here's the point. The serialization itself took about 4 milliseconds. Sometimes it took like 10 milliseconds and so on if I keep doing that. Today is a lucky day, I think. And this is actually some uncontrolled delay that you want to avoid. Some bytes here like that, just to show you what byte arrays are looking like. For some people don't know what's the byte array. It's just like this, literally a byte array of bytes. And then how you interpret as an integer, float, double, and so on, that makes a huge difference in programming languages. That's why you need the serialization. I'm extremely happy about this achievement that I was able to send some images directly from the game simulation to Python. And that's because I was working on my Robotics 101 update. For example, I don't want to compare my simulation with iceoryx by NVIDIA, but iceoryx's image transport is about 10 Hz. But I was able to send the images at like 20 to 30 Hz, and I think that's pretty good performance. So can you imagine a game like you program your turret robot shooting down this enemy alien spacecraft using your image processing and object detection and then the control algorithm? So that's why I was so happy. Also, if you're curious about Robotics 101, check out the link down in the below. Now, I talked about a couple of partial alternative tools than ROS. If you can stick to first principles, then you can use these message delivery systems and serializing systems separately. However, I know that there are some people who are offended by the fact that I don't talk anything good about ROS because they love ROS. And I love ROS. I still use ROS 1 and ROS 2 both. And this is not about superiority or inferiority, nothing about your identity, because every single person have different project requirements. And if you can optimize your project, why not? Why do you have to stick to ROS? I personally, with many projects, I feel like ROS is a jail, it's a dictatorship. So that's why I wanted to share a couple of my workflows and tools with you. And if you're also interested in robot simulation and so on, iceoryx2 is something that I recommend as well. Also, if you're curious about transport-based and then broker-based message delivery system, check out the other video as well. Also, if you're curious about how to build iceoryx for your system, please comment down below. And don't forget to like and subscribe. I'll see you around.